What is the REST API and why is it even used in embedded systems? And so imagine we have the client and the server which are connected to each other. So I write here C standing for client and S standing for the server. Now the server has to give something to the client, right? Because that's why it's called the server in the first place. And so the things that the server gives out to the clients are called resources. And these resources can be anything from the light level, the current time, and so forth. So I could write here T standing for time, and then the L standing for the light level. Now, every resource from the server, in order to abide by the REST API standard, must have an address. And this address is called the endpoint. Now, you might ask me, how does the endpoint look like? Well, it looks like just a logical path in your computer. So you would have like API, then slash light. The time might actually have the endpoint of API slash time, like this. Whenever the client needs a resource from the server, it must send the endpoint of that resource as well as the method, which defines the way the client will use that data. For instance, the get method, which implies that the client will read the data. And after the client has sent this stuff, the server will just send back the response. The collection of all of these endpoints is called the RESTful API. In a nutshell, it represents the way the client and the server communicate with each other. The server is called likewise a RESTful server when it meets the standards of accepting the endpoints relative to the resources available. I'm using the STM32 Nucleo F756ZG, which is connected to the Ethernet port and the USB cable, and I'll open right now the CubeIDE. I'm using the Mongooose networking library. In case you haven't heard about it, just check my previous videos. And so I'm using the Ethernet pins, make sure you enable them, and the UART peripheral as well. Now let me go to the main file and show you the code that will implement this. And so we're just initializing the Mongooose manager, we're waiting till the network is up, and then we configure the microcontroller as an HTTP server. Let me show you the handler function, which can be found up above. And whenever we receive an HTTP message, we will get the HTTP message received, and we will compare it against the API F1 endpoint. If it matches with the URI received, we will just reply with the result, which is 1, 2, 3. For the sake of simplicity, I've written it like this. Now, if we get another endpoint, such as the API sum, we just return the value of the two numbers passed, which are N1 and N2, and we get those from the JSON parsed message. Now, if we don't get these two endpoints, we simply send the HTML file, which is just a web page. It will be found in the web root directory. Let me show you the HTML file. It is not something complicated. We are just creating two buttons, then just some helper functions. And then here is the juicy part. Whenever we click the button 1, the browser will send an HTTP request with the endpoint API F1 so that the microcontroller will receive it and it will send us back the response. Whenever we press the second button, we will call the getSum function. It will basically send another HTTP request with the endpoint API sum with these two numbers, A and B, meaning 1 and 2. After that, we just print on the web page the endpoint sent and the result and the received result. And so all you have to do now is just copy the content of this HTML file. You'll find everything in the description, so don't worry. Now go to the source file and create a new folder which will be called the web root, like this. Now inside it you have to create another HTML file, no, not a header one. So go to again, press on new file, and I'll say here index.html. Click it. I have to open it via System Explorer, so just right click it, System Explorer, and click on the index file and open it with Notepad, and then you have to paste the code like this. Now save it, go back to Cube IDE, and in order to serve the HTML file, we will need a file system which will take care of this. And so there's a utility in Mongooose which allows you to convert the HTML file inside a byte array. So all you have to do now is just go to this repository from Sesanta. You'll have the link in the description. So just copy this content, go back to Cube IDE, and then create a new source file which will be called pect.c. Now click on it and paste the content of it. After you've done that, you have to go again into File Explorer and to compile this file. So click on Show in System Explorer, then go to Source, open the command in this path and just compile the pect.c file in order to convert the HTML file into the byte format. So I'll write here gcc pect.c -o pec like this. Now that you've done this, say pec web root, meaning the path to the HTML file, index.html, and I'll say the result which will be a source file containing the byte format. So I'll say pect fs.c like this. After you've done that, just close out everything and go back to Cube IDE, and let's actually you have to delete the pec.c file because we don't need it. Now flash the program onto the microcontroller, and I'll open real-time to show the content, the content that I'm receiving. So selecting the baud rate, then I'll clear out, and let's see. I will reset the board. Okay, we've got the IP, which is this one. I'll copy this out. I'll go to my browser and I'll say port 80. So we've got the web page. By the way, if you're interested in learning more about embedded systems, you want to get more access to me, I created a free community based on this, in which I host weekly webinars on various topics such as the FreeRTOS, AI, IoT, and stuff like that. So let me press call F1 and see what happens. As you can see, it says here the request, which is get, and then the endpoint, meaning API F1, and the result we got is result 123. So if you didn't understand what happened in the background, the JavaScript code actually sent an HTTP request, and the microcontroller saw that the endpoint received is actually API F1, and this was actually true here. So it sent the result 123. Now if I press on the other button, this will send another endpoint, another HTTP request, and we will get the result 3, meaning 1 plus 2. And so let me show you something. Let me show you how the endpoints look like. So if I go to the developer tools and I press on the call sum again, and as you can see, it says here the sum request, and this is the endpoint that the JavaScript code sent. So it's HTTP, then the IP of the board, and API sum. So that's how the endpoint looks like. This is the address of the sum resource, and the status code is 200 and so forth. If I press on the other button, which is call F1, and click on it, this is how it looks like. The IP of the board and API F1. So I hope you understood how the RESTful API works. Just let me know in the comments what is your view on this. It matters a lot to me, and I'll see you later.